All right, let's see how we can implement this algorithm. Just like always, we want to simplify this problem. We want to narrow it down and focus only on a small part. Once our solution is working, then we'll look at various edge cases. So let's add a new class here. We call it priority queue. Here we want to add a method like add for adding a new item. Now, first we need to create an array for storing our items. Let's say a private integer array called items. And initially, we set this to an array of, let's say, 5 integers. Later, we'll talk about resizing this. Once again, we want to focus only on a small problem. So, what is our algorithm? We want to iterate this array from the end and find the right position for inserting the new item. In each iteration, we get the item at the current index. If this item is greater than the value that we want to insert, that means we want to shift this item forward. So let's go ahead and implement this. We type a for loop. For int I, we set this to. Now here we need another field to count the number of items in our queue. So let's declare that over here. Private integer count. Now we set I to count -1. Why? Because if we have 5 items in our queue, the index of the last item is 4, right? So that is why we have count -1. Now, as long as I is greater than or equal to 0, we're going to decrement I in every iteration. So this is how we can iterate this array from the end to the beginning. Now, in each iteration, we should get the item at the current index. So items of I. If this is greater than the item that we want to insert, we want to shift the current item, which means we're going to copy the value at the current cell to the right cell. So we set items of I plus 1 to items of I. Now, what if the current item is not greater than the value that we want to insert? That means we found the position to insert the new item and we're done with the shifting. So here we simply break out of this for loop. So this for loop is for shifting items. Let's add a little comment here. We'll refactor this later on. Let's just build the first solution. Now, once we're done, we're ready to insert the new item. But where exactly should we insert this new item? Let's go back to our main class and look at an example. Initially, we wanted to insert 2, right? So starting from the back, we iterate this array until we get to 1. 1 is not greater than 2. That means we found the position. But this is not where we're going to insert the new item because we don't want to overwrite this value. We want to insert this new item to the right side of the current item. So 2 should be inserted at this position. So here's the tricky part. After we're done with this iteration, we lose the value of I, and we need this to insert the new item. So I'm going to declare this variable outside of this loop, integer I, and then we use it over here. When we break out of this loop, we are ready to insert the new item. So we set items of I plus 1 to this new item. And finally, we should increment count. So this is our initial solution. Now to test this, let's overwrite the toString method so we can see what we have inside our array. Public string toString. Here, once again, we're going to use the arrays class to convert the items array to a string. And of course, we should apply the override annotation just like before. Now back to our main class. Let's remove these comments. And instead, we're going to create a priority queue object. Now, I'm going to insert 5 and then 3. And finally, we're going to print this queue on the console. Let's see what we get. So our algorithm seems to be working. Even though we added 3 after adding 5, 3 ended up being inserted in front of 5. Now, what if we add 6? That should appear at the end. That is working beautiful. What if we add 1? That should come to the front of the queue. Beautiful. What if we add something that should be somewhere in the middle? Let's say 4. Let's test that too. Fantastic. So we have 1, 3, 4, 5, and 6. Now we have an edge case. Our array is full. So what happens if we add another item? Let's say 10. We got an exception of type array index out of bounds. Where did we get this? On this line. We got this exception here because the number that we tried to insert was greater than all the existing numbers in our queue. However, if you wanted to add a number like, let's say, 2, we would get this exception on line 14, where we are shifting items, because our array is full and we cannot shift items to the right side. So to solve this problem, before shifting the items, we should check to see if our array is full. So we type if count equals items.length. Here we can throw an exception or resize the array. In this implementation, I just want to throw an exception, but if you want to challenge yourself and do a bit more exercise, allow this array to get resized automatically. So here we throw a new illegal state exception. So we're done with the add method. Now let's implement the remove method. That's super easy. Let me show you. So back to the main class, I want to remove the last item so we don't get an exception. Let's see what we have in our queue. So in all the examples in this section, we have assumed that our queue starts from here. So to remove an item from our queue, we need a front pointer that points to the first item in the queue. Every time we remove an item, we simply increment the front pointer to point to the next item. So we can certainly use the same approach in our priority queue, but there is an easier way here. What if we imagine that our queue starts from here? So the larger numbers have a higher priority and they should be processed first. With this assumption, we no longer need a separate front pointer. We can simply use the count field. So every time we remove an item, we simply decrement count. Let me show you. So back to our priority queue class. Let's implement the remove method, public integer remove. Here we want to return the items of count, but of course we should decrement count first. Why? Imagine our queue has 5 items. What is the index of the last item? That is 4. So we decrement count first and then return items of 4. Now, what if our queue is empty? Well, here we need an if statement. If count equals 0, then we're going to throw a new illegal state exception. So this is our remove method. Let's also implement a method to check to see if this queue is empty or not. So public boolean is empty. Here we simply return count equals 0, which is exactly the code that we have on line 26. So we can make this code more expressive and more readable by replacing this expression with a call to this new method. Now let's test all this. So back to the main class. After we print the queue on the console, let's type a while loop. While this queue is not empty, we want to remove an item and print it on the console. So print line queue.remove. Take a look. So our items are coming out in the right order. Beautiful. So we are done with our implementation. Next, we're going to refactor our code and make it cleaner.